Hello class, welcome to Algebra Lesson 6.4, which is all about geometric sequences. By the end of this lesson, you should be able to identify and describe geometric sequences. Example 1, identify arithmetic and geometric sequences. So let's quickly refresh our memories. We learned about arithmetic sequences a couple of chapters ago. And remember, when we talked about those, we talked about how they have a common difference, meaning you can either add or subtract the same amount each time and end up at the next number in the sequence. Geometric operates the same way, except instead of addition or subtraction, you guessed it, multiplying or dividing. So let's look at letter A. Our sequence is 3, 2, 4 thirds, 8 ninths, 16 27ths. So if I look at that, I can see clearly that they're not adding or subtracting by the same amount each time. Because if I was going from 3 to 2, that's minus 1. That means when I subtract 1 again, I should end up at 1. Which is not what I have in that sequence. So I know for sure right off the bat, letter A is not arithmetic. But let's check geometric. So what you do is you take the second term in the sequence, so 2, and then you divide it by the number right in front of it, 3. So I would get 2 thirds. Then what I'm going to do is I'm going to take 4 thirds and say divided by the number right in front of it, which is 2, and 4 thirds divided by 2 is 2 thirds. And I would keep doing that. Now I would do 8 ninths divided by 4 thirds, and if I did that, I would get 2 thirds. Then I would do 16 27ths divided by 8 ninths, and I would get 2 thirds. So you can see that this has a common common ratio. Common difference is when you add or subtract by the same number. This is definitely common ratio. So my common ratio would be 2 thirds. So I would say this is a geometric sequence. And then I'm done with letter A. Let's look at letter B. We have 3, 4.5, 6, 7.5, 9. So to go from 3 to 4.5, I have to add 1.5. To go from 4.5 to 6, I have to add 1.5. From 6 to 7.5, I add 1.5. And surprise, surprise, to go from 7.5 to 9, I add 1.5. So since I'm adding by the same amount each time, this is considered an arithmetic sequence because it has a common difference of 1.5. So make sure, common difference goes with arithmetic, and then with geometric, it's common ratio. Okay, so make sure you keep those terms straight. That means that you need to make note cards to help you remember that, do that. If you need to write this down a few times, do that. You need to remember that information. All right. Question number 1, is the sequence an arithmetic or geometric sequence? Why don't you take some time and figure this problem out on your own? Good luck. All right, for this problem, hopefully you figured out that it had a common ratio. It's being multiplied by 2.2 every single time, and you ended up with saying that it's a geometric sequence because the common ratio. All right, example 2, write a recursive formula for the sequence. So again, let's draw on our previous knowledge. When we talked about arithmetic sequences, we learned about recursive and explicit formulas. Recursive, remember, is the one where you have to find every single term before it in order to get the next one. Okay? So that's what we're going to look at right now. How do we use a recursive formula for a geometric sequence? We have 8, 12, 18, 27, 40.5. So our recursive formula, I took a screenshot and included it right here to help you remember. I recommend, again, writing this down. Take notes. You have to memorize these things. I'm testing you on your knowledge for this, so you need to remember what these stand for, what they are. Okay? So, the recursive formula, A of n represents whatever term we want it to represent. So for now, I'm going to leave it as A of n so we can pick the term later. Then, r is our common ratio. So let's figure out, how do we get from 8 to 12, 12 to 18? Since that one's maybe not as obvious to people, what you're going to do is you're going to take the second term divided by the first term, and 12 divided by 8 reduces to 3 halves. And then if you want to check to make sure that you have that right, just do the next one, 18 divided by 12. And again, 6 goes into 18 3 times, 6 goes into 12 2 times. So my common ratio is 3 over 2, and then I would just say that it gets multiplied by whatever the previous term was. Remember, we represent the previous term with that entire a and then subscript, that little script down below, n minus 1. Okay, so that would be our recursive formula for this sequence. And remember, with recursive formulas, you always have to give what the first term is so people know where to start. So our first term is 8. So I would need to list both of these pieces of information for the geometric sequence when I'm using recursive. Your online book is going to swap between using A1, like first term, or initial condition is another phrase that they use to describe that first term. Okay? So it'll be called either A of 1 or initial condition. They mean the same thing. All right, I want you to try writing a recursive formula for this geometric sequence. Good luck. Okay, for this one, hopefully you came up with a common ratio of 1/4, and you said A of n equals 1/4 times A of n minus 1. Okay, and then you said the first term is 3072. If you have questions about that, please be sure to reach out and ask for some help. Example 3, use the explicit formula. Okay, so we've learned the difference between arithmetic and geometric sequences. We've now learned how to do a recursive formula for a geometric sequence. Now let's talk about the explicit formula for a geometric sequence. Remember, explicit formulas are helpful because if you want to find, say, the 100th term, you don't have to find the first 99 in order to get to that 100th term. You can use the explicit formula and jump straight to that 100th term. Okay? So again, we're using that same sequence, 8, 12, 18, 27, 40.5. So that means that my ratio is the same. It's still 3 over 2, my common ratio. But this time we're going to write an explicit formula. So you always leave A of n, because remember, that's where we get to plug in later when we're trying to find the 100th term or whatever term. In this example, we're trying to find the 10th term. But for now, I'm going to leave it A of n. Then you're going to write in whatever your first term is. In this case, that's an 8. Then you're going to do some parentheses, write in your common ratio, which is 3 over 2, and then you just say n minus 1. Now to continue solving, so that's my explicit formula, okay? So I've written my explicit formula. I would be done writing it if it just asked me to write the formula. But it doesn't. It asks me to find the 10th term. So I'm going to say A of 10 to signify that I'm finding the 10th term equals 8, parentheses, 3 divided by 2. And then I can do the caret key, and I do 10 minus 1. Well, what's 10 minus 1? Faster way of writing that, instead of saying 10 minus 1, I'm going to say 9. So I'm going to type into my calculator 8 parentheses 3 divided by 2 parentheses caret 8. And when I plug that number in, I get a number that is approximately 307.55. Okay, I rounded to the nearest hundredth. That decimal does continue, so if your number didn't end at 0.55, that's okay. I rounded. So as long as you had 307.54, and then I don't remember what the next number was, but it rounded up. Okay, if you have questions about that, please ask. This is another formula you need to make sure you know. You need to make sure you memorize. So again, I've been encouraging you to make some flashcards or write these down. I cannot stress that enough. Example 4, connect geometric sequences and exponential functions. This whole chapter is about exponential functions, right? So how are they related? So if I want to find the number of subscribers to a blog that doubles each week, And how can this trend of subscribers be modeled? Well, if I go back to my previous knowledge of what an exponential function is, a times b to the x power, right? So I could say f of x, and then remember a represents the initial amount, and then b represented how much it's changing by, and then you would just say x. Or I could use an explicit geometric formula, and I could say a of n equals my initial amount, my a1 term, times the common ratio, n minus 1. So both of those, you see how they look similar? They have the 5, they have that starting value, times, and then whatever the number is, the rate of change is, whether it's rate of change or the common ratio, that gets raised to a power. So both of these would be correct ways to write formulas for this problem. You just have to pay attention to what it specifically asks you. This one didn't specifically say use a geometric or use an exponential, so that's why I showed you both. Okay, let's look at the second part of this question. How many subscribers will there be in week 9 if the initial number of subscribers is 10? Okay, so I see a little bit of important information there. Assume the number of subscribers doubles each week. Okay, so I'm going to take my geometric sequence that I had on the last page. So it was a of n equals, and then I actually, just kidding, I'm going to change it a little bit. Because my initial amount, we're no longer saying that our initial was 5 subscribers. We're now told the initial subscribers was 10. My common ratio is still 2 because it's still doubling. And then week 9, I'm going to say 9 minus 1. So I'm looking for the 9th term. So if I were to plug this into my calculator, 10 parentheses 2 parentheses, then you can do the caret. 9 minus 1 is 8. When you plug that in, you get 2,560 subscribers is your final answer. Okay. Let's look at our last example for the day. The number of people attending the annual Town International Food Festival has decreased by 20% each year since the first year. How can attendance for the first 5 years be modeled? Okay, so decreased. I'm going to pull on my previous knowledge from this chapter. Decreased, the word decay comes into my mind. Remember, decay we represented by 1 minus r. So I'm going to say 1 minus 0.2. That means that my rate of change is going to be 0.8. Okay? So then I'm going to write in a of n equals 0.8. Actually, pause. I'm going to show you both the recursive and the explicit. So recursive would be a of n equals 0.8, because that's my rate of change, times whatever my previous term is. So a of n minus 1. And my first term is 1,250 because the poster tells me how many people attended. If I were to want to write an explicit formula, I would say a of n equals my first term times my rate of change to the n minus 1 power. So that's how I would modify, or how I would model those equations, those formulas. Then, once I've done one or the other of those, you didn't have to do both, I just wanted to show you both ways. If this trend continues, what will the attendance be in 10 years? So if I use my recursive, that means I have to find the next 9. Like, I have to find every single term. My preference is gonna be to use the explicit. So I'm gonna say a of 10 equals 1250 times 0.8 10 minus 1. So 1250 times 0.8 to the 9th. And when I do that, I get about 167.77 people, but we can't have partial people, so I'm going to round to 168 people. That's how many people you can expect to attend this event in 10 years, if this trend continues. All right, so here's our concept summary. You have your explicit formula, you have your recursive formula. Make sure you know how to use both, do both. If you have questions, please do not hesitate to reach out for some help and ask for help. I am more than happy to help you. Have a great day.